Dear students, we are continuing with our chapter circles. Okay, this is the last part of the portion. Some properties, chord properties, and some small theorems have been there. The first theorem is a straight line drawn from the center of a circle to bisect a chord which is not a diameter is at right angles to the chord. So you have familiar with what is the center of the circle. Bisect, how will you bisect? What is bisect means, and a chord also. Okay, the figure is given here. A circle is drawn. O is the center of the circle. Okay, and a straight line drawn from the center of a circle to bisect a chord. So AB is a chord drawn which is not a diameter. The chord is not a diameter, and AB is drawn. First you have to plot the center of the circle O, and then you have to draw AB, the chord AB, and then draw a straight line from O to AB, okay, and which bisect the chord, which means the chord will be in half. Okay, that is OC. C is marked there. Then AC and CB are equal. Okay, AC and CB are equal. You have to prove that OC is perpendicular to AB. That is, angle OCA and OCB are right angles. Okay, that is OC perpendicular to AB. That's you have to prove. Then for that, the construction is you have to join OA and OB. Okay, and then you will get in triangle OAC and triangle OBC, OA and OB are equal. OC is common, so it is equal. OA and OB are equal because they are the radius. Okay, and OC is common. AC is equal to CB because OC intersects AB. That is also given. And then by SSS, three sides are equal, so the two triangles are congruent. Since the two triangles are congruent, the angle including the angles in these two triangles are also equal. Okay, that is angle OCA and OCB are angles. That angles are equal because these are the angles of the congruent triangles. But angle OCA plus angle OCB is 180 degree. The sum is 180 degree because ACB is a straight line. So the angle is 180 degree, and since that means angle OCA is equal to angle OCB is equal to 90 degree. Okay, these two angles are equal, then the two angles should be 90 degree. Okay, yes, so we have proved that OC perpendicular to AB. Okay, so this is the theorem. Theorem is a straight line drawn from the center of a circle to bisect a chord which is not a diameter. The chord should not be a diameter. It is at right angles to the chord. Okay, yes. And next is the converse of this theorem is also true. That is, the perpendicular to a chord from the center of the circle bisects the chord. That's also important, but you have the proof is not there. You don't have to study the proof of this theorem. Okay, just study the theorem. So the first theorem is here and the proof is important. Okay, and the second theorem is the proof of this theorem. Converse of this theorem. You have to just study the converse of this theorem, not the proof. Okay, next theorem is equal chords of a circle are equidistant from the center. Equal chords. So you have to draw two chords. The two chords are AB and CD. What you have to prove is a circle with center O in which the chord AB is equal to chord C. You have to prove is the chords AB and CD are equidistant from the center. What is the center of the circle? It is O. So if we draw a straight, if we draw a straight line from the center, that is OP and OQ. You have to prove that OP is perpendicular to AB and OQ is perpendicular to CD. Then you can prove yes, OPC equal to OQ. Okay, for that you have to join, the construction is join OB and OD, and since the perpendicular from the center bisects the chords bisects the chords BP. What is BP? BP is half AB. Okay, half AB. Then DQ is equal to half CD, because in the previous theorem we have the straight line bisects the straight lines drawn from the center is make a right angle at the chord. So the chords are perpendicular, that we have, and then DQ is equal to 1 by CD and BP is equal to 1 by AB from the previous theorem. And then AB is equal to CD, which is given because the chord are equal. Therefore BP is equal to DQ from 1, 2, 3. From the previous two statements we get a BP is equal to DQ. Since the right sides are equal, left side are also equal. Okay, and we have taken the two triangles, triangle OBP and OQD. These two triangles have been taken, and from that triangles two sides BP and DQ are equal. Okay, and OB equal to OD, since they are the radii, and angle OPB and angle OQD are right angles and they are also equal. So from this three types, it is first an angle is right angle, a side is hypotenuse is equal, and a side is also equal. So it is RHS. Using RHS we get the two triangles are congruent, and since OP is equal to OQ are the sides of the congruent triangles, they are also equal. So we have proved the theorem. Okay, this theorem is also important. And equal chords of a circle are equidistant from the center. I think all of you understood the proof also. Okay, next is the converse of this theorem. Chord of a circle equidistant from the center are equal. Okay, you don't have to study the proof. Okay, you have to study the theorem only. And next is another theorem. There is one and only one circle which passes through three given points and which is not in a straight line. One and only one circle which passes through three given points which is not in a straight line. Okay, for that ABC, a circle is drawn with center O and ABC is drawn. Okay, ABC is drawn, is marked, points are marked. Okay, ABC is marked, 3 points ABC which is not in a straight line. Okay, and then you have to prove is one and only one circle can draw through draw through A, B and C. There should be only one circle should be drawn through A, the point A and B and C. Okay, that is the construction is given here. Join AB, BC, join AB. AB is the first 2 points and then BC, and draw perpendicular bisectors of AB and BC and let these perpendicular bisectors meet at point O. So perpendicular bisectors has been drawn there. For AB, the bisector is drawn as a straight line. For BC, another bisector is drawn, and this should be meet at the center of the circle O. So like look at that, the center of the bisector O is, the bisectors are meeting at O. Okay, that is the construction. And now the proof are O lies on perpendicular bisectors of A, therefore OA is equal to OB. Okay, because what is the reason? Each point of the perpendicular bisector is equidistant from the extremities of the line. Similarly, next one is OB is equal to OC, because perpendicular bisector of BC. Okay, I think you have been, yes. First one is OA is equal to OB, OA is equal to OB, and OB is equal to OC. Since the perpendicular bisectors, yes, the perpendicular bisectors have been equidistant from the extremities. So you from the above to equality, you will get OA is equal to OB, and by that OB is equal to OC, which implies, yes, O is equidistant from A, B, C. That's why you will get the three, yes, distance are equal. That is, if a circle is drawn with O as a center, then OA as radius, this OA as radius, then it should be passed through B and C also. Okay, and then similarly, since since bisectors AB and BC cut each other at a point O only, okay, then O is the only point equidistant from A, B and C. Okay, that is one and only one circle can be drawn through points A, B, C and not S, which is A, B and C are not in a straight line. If A and B are not in a straight line, we can draw only one circle which passes through A, B and C. Okay, this is the proof. Okay, and some problems has been given for you. Okay, yes. Next is another theorem. This theorem is not so important, but if two arcs of the same circle subtend equal angles at the center, they are equal. Two arcs are given, and if that two arcs subtend equal angles from at the center, then the angles are equal. Okay, that is, you have to draw a circle with center O, and arc are drawn APB and APB and CQD. Two arcs are drawn from the center, and that subtend angle to O. Arc are subtend to angle O, and that is angle AOB and COD are equal. Okay, you have to prove that the arc APB and arc CQD are equal. If the two arcs of the same circle subtend to the center, okay, equal angles, and the subtend to center and the angles are equal, then you have to prove that the arc are equal. So for that you have to draw arc from A to B and C to D. Okay, that's the second figure. AB is joined and CB is joined. Angle AOB and angle COD are equal also. So taking that triangle AOB and triangle COD, OA is equal to OC since the radius, and OB is equal to OC, again radii, and the given angles, angle AOB and angle COD are equal. So by SAS, two sides and the including angle are equal, you get angle AOB and angle COD are equal, which means the chord AB and chord CD are equal. Okay, so the chord AB and CD are equal, which means the arc APB and the arc CQD are equal, because equal chords of a circle cut equal arcs. Okay, so this is the, yes. Next is the converse of this theorem. If two arcs of a circle are equal, then the subtend equal angles are at the center. Okay, this proof is not important. So this is the arc and chord properties. So these theorems are the proofs. The four theorems have been proved there. So you have to study the theorem and the proof. The converse theorems are just study the theorem only. There is no need to study the proof. Okay, the proof are excluded in your syllabus. Okay, proof of that theorem. So the four theorems are very important. Please study the please write the theorem and write the proof also in your notebook. Okay, so this chapter is for your third midterm examination, chapter 17 until this theorem. Okay, so these are the important theorems also. Please study these and write the notes also. Okay, thank you students, have a nice day. And also there is a problem here. Okay, according to that theorem you have to solve the problem, and also this exercise according to these theorems you have to solve these exercises also. Okay, yes, thank you students, have a nice day.